All right, let's have a look at this one. So we've got our 4 adults and 5 exits. So if we think of those 5 exits like A, B, C, D, E, for example, then each of those adults has a choice of 5 different ways to go. So you could also think of it like entree, main, next meal if you had four different meals. So that the first, there's 5 for the first adult, there's 5 for the second adult, etc. So if each adult has 5 choices and you've got 4 adults, then I'll just put 5 to the power of 4. So in total, the number of combinations, so the first one might choose A, then the next one might choose A again, then B, C, C, that's 4. No, 4 adults. There are only 4 adults. Take that back. 5 exits, 4 adults. All right, so you might get something like that, or we could have got A. We could have got B, C, D, E, etc. So all the different number of combinations would be 5 to the power of 4. So that's going to be our denominator for the probability of, let's say, same. So all the same. So if they all chose the same, they either all chose A exit, B exit, C exit, or a D or E exit. So there's 5 different choices. So you can see there we would have 1 on 5 cubed or 1 on 125. So now if I look at B, the probability this time that 3 particular adults use the same exit and the 4th adult uses a different exit. Now note it does say 3 particular adults, so it's like they've already been picked. All right, so these 3 adults have already been picked. So 3 the same and then 1 different. So same denominator because there are that many combinations that could actually occur. Now if you think of 3 in the same, those 3 could be in the same of any of those 5 exits. So maybe they're all in the first exit, second, third, fourth or fifth. So there's 5 choices for those first 3 particular people to go in. Now the last person has to go in one of the other 4 doors, not that one that the others went through. So they have 4 choices. So there you can see if I cancel 1, 5 from both top and bottom, I'm going to have 4 on 5 cubed or 4 on 125 for that one. And then in C, so they're very similar, except this time, so it's 3 and different, but this was a particular 3. And now we're finding the probability of any 3, as opposed to a particular 3. All right, any 3 of the 4 adults. So it's the same question, same denominator, it's still out of 5 to the 4 different combinations, but this time we've got to choose which 3 are going to go through the same one. So how many do we have? We've got 4 adults, so I'll probably just go 4, choose 3. So I'll choose which 3 go through, so it could be those 3 or those 3 or those 3, Once we've chosen which 3, they can choose which door they're going to go through. And then the last person, the little odd person, has now got 4 choices of exits because the only one they can't go through is the one that the other 3 have gone through. All right, so if we have a look at that, that should be 16. 4 4s are 16 on 5 cubed because the 5s will cancel. So that's 16 on 125. And the last one was the probability that no more than 2 come out of any one exit. No more than 2. So no more than 2 is the same as 1 minus, I should say the probability, 1 minus the probability of the opposite. So that would be 3 coming out the same and 1 different, or 4 coming out the same. All right, 3 same, I should say, and 4 same. So it's easier to do it that way, I think, because we've already done 3 in the same, and 4 should be much easier. So I'll do it down here. So we've got 1 minus. So we've already done 3 the same up here and 1 different, which is 16 on 125. And I also want to get rid of 4 the same. All right, so what would 4 the same be? Well, would have the same denominator, but this time we'll have, if 4 are the same, they just have to choose, excuse me, they just have to choose 5, and I didn't write down the answer here, so that was a bit of a bummer. So no more than 2 adults coming out. So, oh sorry, what was I doing? Yes, the probability of 4 here. So the probability of all 4 coming out the same door. So they could choose 5 different ways out of the 5 to the power of 4 different ways, which is 1 on 125. Yes, 1 on 125. So all adults coming out the same door. There's 5 choices. Yeah, that makes sense. So I've got 1 minus 125. Take away 17 is 108. So it's 108 over 125, which is, oops, anyway, 108 over 125. All right, hope that helped.